plenty of those. Anybody still missing a ruler? Any kind of straight edge will work, by the way. We're going to do two things today. We're going to construct a perpendicular bisector for a segment, and we're going to bisect an angle. Anybody else need a ruler? Straight edge. Your iPad will work too, for that matter, and your phone. Okay. Hey, guys. These are constructions. If I use a program called Sketchpad or my Inspire software, and if I want to create a square, I actually have to construct it. I have to construct the right angles. I don't measure it with a compass. I'm going to do what I'm doing right now. Right now, I'm going to do this. We're going to do this with a compass and a straight edge. So first we're going to do is create a perpendicular bisector. Now the problem is which came first, the chicken or the egg? This is kind of the same problem. I can do these constructions so you start to see relationships. Or if I know the relationships, you see why the constructions work. That's the problem. So I'll kind of talk a little bit about it. Okay, so we're going to do a perpendicular bisector. So first thing I have to know is what is that? A perpendicular bisector is a segment. It could be a ray, or it could be a line. Any one of those three things, doesn't matter. Okay, Lindsay, you should write it down. And this ray, or line, or segment is perpendicular. Now, I don't like to write the word perpendicular, so I draw the little symbol. And you know what perpendicular means? These form right angles. And what's the measure of a right angle? 90. When my daughter was in second grade, they were doing right angles. So I know you know what they are because it was second grade. But what was funny about it is the teacher said it was a 90-degree angle. But she didn't understand measurement in degrees. And she was thinking 90 degrees, like a temperature. So she thought it was a hot angle. But she was only second grade. So, but I will never forget that little story because it's kind of cute. So that's a 90-degree angle, and hopefully you'll never forget that now. And my segment is going to be perpendicular. I'm sorry, my line is going to be perpendicular to my segment. And not only that, it's going to divide the segment into two congruent segments. Divides the segment, not a line. Line has no beginning or end. Into two congruent. Again, I don't like to write the symbol, write the word, so I write the symbol. Segment. And yeah, you could kind of guess and check, but that's not going to be exact. I want exact. So we're going to do a construction. So what's going to happen? There's my segment. Can't have rays. It has to have endpoints. And I'm going to construct the line that cuts this such that these two parts are equal in length, and this forms a right angle. That's a perpendicular bisector. You know what each word means. You know what perpendicular means. You know what bisect means. Just put the ideas together. Okay, ready? How do you construct one? Well, first you got to draw a segment. That kind of helps. Draw a segment. And we will do this more than once because we are sharing these. And then I'm going to put my compass point on the end points. So here's my segment. And there's an infinite number of points, but I have two very special points. And those are the end points. The rule of thumb when you work with a compass is you want to put the compass point on one of those special points. Not just any old point, but a special one. So I'm going to put the compass point here, and I'm going to draw like a little arc. The compass point's going to be at A, and I'm going to do the same thing at B and draw an arc. Keeping the same opening. Do not change the angle. So at each endpoint, draw an arc. And the arc should intersect. I don't have enough room here. I'll be nice. I'll write the word out instead of using the symbol. Oops. And then I have two more points. I've got this point right up here and this point right there. Call that E and call that F. And if I draw the line containing E and F, I have a perpendicular bisector. So connect the intersection points well, you can do it with a line, a ray, or a segment. It doesn't matter. And before we do the construction, let's look at what's happening. Yeah, you could use a ruler. Of course, you could, but that's not what we're doing. Now make sure you know how to do these because we are going to be doing this on your test. So I don't know what we're going to do about compasses. I'll have to figure that out. So let's look at what we're doing. Yeah. And this is all gets saved. I save this as a PDF file, so if I do go too fast or lose you, you can always go back and look at it. I put it up on Schoology. I've been really good about keeping up to date with that. And then I also have the videos. So if you get stuck during some of this, you may say, I got to go back and do that again. Well, there's the video. Watch it. And actually what I'll do is I'll just come down here. I want you to understand what's happening. Well, let's just use AB. When I put my compass point here and I draw this arc, what's true about all these distances? It's just part of a circle. They're equal. And when I put my compass point here and I draw a similar arc, guess what? These distances are equal because I kept the same opening. So these are all equal. And this is equal to itself. And I really can't give you the theorem, but this triangle here is equal to or congruent to that triangle. Therefore, this segment and that segment will be the same length. Kind of the Y's. But we don't have all the theorems about triangles. So I kind of have to gloss over it. Well, I'm going to do that right now. I'm just trying to talk about what's happening. These triangles are the same triangles. If you cut them out, laid them on top of each other, they would be exactly the same in all ways. Okay, so let's try this. I have to get my compass out. Now you guys are going to have to share. I'm sorry. At each endpoint. So I'm going to do it. I'm not just going to say, oh, that's what you do. Okay, this happens to remember what color I was with. I think I want to change the color, though. Let's make it green. Now, if you open this and it's less than halfway, and you make your arc here, and then I have to flip this over and put it at the other endpoint, and I make a similar arc, are they going to intersect? No. So that's a problem. So I don't think, can I erase this? No. So you have to make sure that you actually open the compass setting so it's bigger than half the distance. Yes, you are eyeballing it. Now I like to go left to right, so I'm going to put this over here. So I want this opening bigger than halfway. So that's pretty safe, isn't it? Now you're not going to erase your little marks. You're going to leave them there. And so I'm going to make an arc. Basically, whoops, a semicircle. Now the hard part, of course, is don't change that opening. Easy on my smartboard. Question? Zach? Okay, you put your compass point on one of the 2 points. How many points you got? 2. There's only 2 things you can do. You just draw a semicircle. That's a semicircle. Everybody get that? Keeping the same opening, there's only, well, actually, there's 2 places. I could put the point there, but that doesn't seem to make sense. I'm going to put it at B. I want to repeat the process. So I'm going to flip that, and I'm going to slide this over here and put it at B. I haven't changed the opening. I want it the same. And I'm now going to do this until I get some intersecting arcs. There it is. Question? Yeah. Tell them what you need. Okay. And what's the only thing I can think of to do with those points? Yeah, let's use them. Let's draw the segment. Now I'll have to fix this a little bit. Or maybe not. That looks not bad. Sorry, I don't know why I can't. Whoops. Why it does a thick line, I don't know. Okay. What's true about this length and this length? Aren't they the same? They're congruent. The segments are congruent. And this length is congruent to itself. And then I need a little bit more, but basically this triangle is congruent to that triangle. Therefore, this segment's congruent to that, and that's going to give me right angles. In fact, you're going to find things in triangles that'll be interesting coming up. That's all there is. Now, what you can do on the next problem is rotate your paper. I can't rotate my smartboard, which then, of course, causes problems. We want segment AB. So I'm going to highlight it. You can either, it's this guy. Question. Do you want to pass it back? Or it's mine, whatever. Okay, I want to do a perpendicular bisector to this. What would I do in my homework, honestly? I'd turn my paper, because I like to do my segments parallel to the floor, but I can't. I can't turn it. So I'm going to have to just work with it. So I'm going to slide this, and I'm going to put my compass point on one of the 2 points. I'm going to make sure this opening is more than halfway. Looks like it's more than halfway. You don't. You can't bisect the point. No, it doesn't. Segment. Be careful. We need to say these words carefully. Because that's how you're going to communicate. If I'm in France or if I'm in Spain, I better know the vocabulary. What number are you looking at? Number 3 on the homework. You're not reading it correctly. It says bisect, angle AB, A, angle B, angle C. I haven't done that yet. We are constructing a perpendicular bisector. You need to use a compass on this. I don't see the tick marks. And a straight edge. Okay. So we're going to mark this. I have to have a semicircle here, basically. Now, all I really need are the arcs at the extremes here. And now I am going to flip that over and put my compass point on B, the only other point I had. Not the new one. And then I'm going to make that arc. You see what's going to happen there? And I get this point here and this point here. And guess what? If I draw that line, that will be it'll be perpendicular to that yellow segment, and it will bisect it. They're kind of fun. I like constructions. Well, you can be creative and construct some difficult things. These are still fairly easy. There are harder things that we're going to do. Right. Do you want to do another one of these segments, or are you feeling comfortable? Okay. It is interesting, if you bisect all 3 of those lines will be concurrent. Remember what concurrent means? They will intersect in a single point, a very special point that we will learn later. I forget what the name of it is, but I'll have to just learn it myself. Okay, ready to bisect an angle. Okay, you have an extra spot there. Okay, angle bisector. Here's my angle. Remember, an angle is made up of 2 rays that begin at an endpoint. Does that sound weird? Rays that begin at an end point, but they do. An angle bisector is a segment, line, or ray that if you start at this endpoint, it divides this angle into two congruent angles. That's an angle bisector. Now I'm going to write it. Okay. It is a line, segment, or ray. What did I draw? By the way, what's my red picture up there? Is that a line, segment, array? It's a segment. Good. Usually I do rays, but I didn't. Okay. That divides, I'm lazy, an angle. It's universal, those symbols, so if I can go into Japan, I can use those same symbols into two congruent angles. Two congruent angles. Question? Okay, now, if you think about it, there's only one place to put your compass. There's only one place to put your compass on your angle, at the end point. So, place the compass point on the end point. Draw an arc so that it intersects both rays. I'm not sure how many steps they're thinking. That's all personal preference. Draw an arc intersecting both rays. So I'm going to do my angle ABC. I better get a compass, I guess. Doesn't seem fair, does it? I have a nice little compass here. And, you know, A and C are just ways of naming the angle. The only point that's really significant is B, because that's the vertex. Endpoint. I should have said vertex. Vertex is better. Okay. You ready? Open the compass up. You could do a little arc, but you're going to have a bear of a time finding it, so I'm going to make it bigger. And I'm going to draw an arc here. Kind of like copying an angle, which you probably forgot how to do. Copying an angle, then, I want to measure where these intersection points are. I want to measure that length. I'll do it with a compass. And we can come back and look at a homework question on that, okay? But I want to bisect the angle. I can keep the opening the same, or I could change it, but I got to go more than half the opening. So I'm going to slide this guy. And you know what? There's only one place to put that point. First, I started with one point, the vertex. A and C don't matter, because those are just to name the angle. They're irrelevant. There's no measurement to them. But now, what's true about these two segments here? This segment and this one. They're congruent. This one's easier to prove. Now I'm going to draw an arc. Make sure you make it big enough. And now I'm going to go to the other point. We had this point here. Whoops. See that way. That's what I think. I have that point there, and I have this point here. Turns out it intersected with this arc, but I don't really care. That was by chance. Put the point on the other point, flip your compass over. And if you want me to change the color, I will. I'll change it to red. And I see where those intersect. What's true about the distance from here to here and the distance from here to here? They are equal. So if I were to draw from B to this intersecting point, which I'm going to do, I'm going to draw a segment. Then if I were to color those triangles, which I will, this triangle is the same as this triangle. Well, if it's the same, then all the parts in there are the same. Oh, if I have a triangle, but then that means that this angle would be equal to that angle. Okay, so I guess I better get some steps in there. I've got the one at the vertex. Now, place your compass point at these intersecting points. So place the tip of the compass on the points where the arc intersects the rays. Whoever thought this would be an English class, huh? Make sure your partner has a chance to try this. Draw the same size arc from both points. And connect the vertex to the intersection point. Remember, I will be looking for your tick marks. Okay, ready? Oh, sorry. I'm going to do DEF. We're going to bisect an obtuse angle. I'm sorry, what? You don't have to put tick marks, arcs. So let's do it again. Let me grab this guy. Let me flip it over. And I'm going to start at vertex E. I don't want blue. Should we do red? Okay, doesn't matter how big an arc you make, but if you make it really small, if you go in, don't do that. If you go in here, it's going to be hard to work with. So make it big enough so you can work with it. And then we're going to rotate that. There's that one. I could pick it up. I'm just going to draw the complete arc. And there's that one. Guess what? I've got two new points. I've got this point, and I've got that point. The only place I can think of to put my compass is right on those points. No, don't do that to me. Okay, now I'm going to pick up my compass, and I'm going to put it here. I can change the opening, so how about if I change the opening so you can see it doesn't matter. And let's change the color. Let's go to black. Now I have to keep the same opening when I go off of this new point and that new point. And now I'm going to take this, and I'm going to put it on F, but I'm going to flip it over. And then I'm going to do that. So it's a different size arc, but that's okay. The arcs from these new points are the same. And notice it happened to go, it didn't even go through D. What am I thinking? And now we'll draw the little line. If we need to do it again, we will do it. Oh, we are going to do it again. There it is. Yes. Because I don't know where this point's going to be. I'm basically creating a triangle. These are equal, and then if I do this and this, these are equal, and this triangle then is the same as this triangle. If they're the same triangles, then these angles have to be the same. Here's compass. Here's the thing. When you create new arcs, you will create more points. And that's my rule of thumb is I don't know what else to do. So I'll put it on one of the new points I created. Now, I only want angle OMG. What's the vertex for OMG? Name it with one letter. Angle what? M. So I'm going to do this one. I want to bisect that one. Now, I have colors over there, so feel free to use my markers. That's why they're there. Oh, Better put my compass. Now, if you did this and your partner didn't get a chance, let your partner do this. Okay, I got to flip it. It's kind of, I like to start there. Only one place to put my compass point, and that's at the vertex. That's it. Okay, what am I going to do? I'm going to draw an arc keeping the same radius. Now, I don't really know where G and O are. MG and MO might be the same length. I don't know. But I do know that MA and MD are the same length. I know that. Where's the only place I can put my compass point that even makes sense? Right here at A and D. If the opening's not big enough, you're going to have to change it. You just have to make sure. First? No, you want to put on D first? No. But I got to do this. Oopsie. Okay, now I want to get where this arc is going to intersect here. So I'm going to just do this. And now I'm going to flip this back. And I'm going to go put this on this one. And there it is. Those lengths are the same. This is what I'm saying. It's kind of like which comes first. We don't know anything about congruent triangles. But if I did know triangles are congruent, this would make total sense. Because you just have to believe me, that's the angle bisector. Now I got to draw the segment. Or ray. Let's do a ray, dotted line ray. There it is. Oh, I didn't get that centered right. You need, only way you're going to get good at this is to practice. These assignments aren't that long.
No, 3.
I don't know.
Bisect all the angles.
Yeah, and interesting, when you bisect all the angles, do they meet in a single point? Remember the word? Are they concurrent? Yes, they are. If I draw the angle bisector to this one, I'm going to just eyeball it. And this one, whoops. Yes, they should meet in a certain point. And I think on this one, if I draw a circle, I don't know which way it is. Oh, yeah, I do. I could put this in a circle. If I do it right, it'll be perfect. You know, that wasn't a bad circle. That's a really good circle, you guys. Okay. How about copying an angle? Did you have problems with that, or should I review it anyway? Oh, yeah, you have time tomorrow to work. Don't forget that, unless you're a sophomore. Sorry. I'm going to copy this angle. Okay, to do this, I must have another line of some sort. I think copying angle is harder than the bisecting one, honestly. Okay, guess what? There's only one place to put that compass point, and it's at the vertex. That's unique. It's very special. All these are a whole bunch of points. Which one do you want me to put at? This one is only one of these guys. So I'm going to put it here, and I'm going to open this up, and I'm going to change colors, and I'm going to make a little arc here. So it's just like the last one we did. So I'm going to do it over here. I'm just going to, because I want to copy it. So I want the same size opening in the same place, same location. Now what I have to do is measure how wide that opening is. Well, I put the point at one of those intersecting points, and then I put the pencil point at the other one, maybe. Hang on, I got to rotate that first a little bit. Okay. Rotate it a little more. Okay, guys, you know what you're doing? I want to measure that opening. Keeping now your compass steady Well, guess what? I don't have a point to put that at, but I do here. So I'm going to just flip it over, mark it, and there it is. I now copied my angles so they are congruent. I'm measuring this with my compass opening. When I put the point back down, it's got to be on this line here because I don't have another point that's special. Which one do I put it in? Okay?